What's going on, everyone? My name is Johnny Bandon, and this is part 2 of our NAT video series. So we just left off going over the NAT terminology, overview, and why we use NAT, and now we're going to dive into the different types of NAT. So the first NAT we're going to go over is static. So static NAT provides a one-to-one mapping of a local or private IP address to a global or public IP address. So these are mappings that are going to be statically configured by an administrator, or you, the network engineer or administrator, and they're not going to change until you administratively change them. So as you can see here in our static NAT table, we have to have one-to-one mappings, meaning if we map this server right here to this inside global address, which is going to be this IP address right here sitting at R2 out towards the internet, that's the only system or endpoint that's going to have connection out to the internet. And that's because static NAT is a one-to-one mapping. So when it receives packets from these other users or clients, it's just going to discard them when they want to reach the internet. Now, let's say we have a unique scenario where we got 3 connections out to the internet and we have 3 global addresses. Well, then you can add more IP addresses to be translated, but it's still a one-to-one mapping. They can't overlap, and this IP address can't use this global address. Not going to happen, right? It's just a one-to-one mapping. So when is there a use case for this? So sometimes there's a use case on your server when you want to protect it. Let's say you just have maybe one server cluster. So you have a server cluster, and they all have 10.10.10.0 IP addresses. So let's say this is .1, this is .2, this is .3. Then they're all connected off, here's our switch here, to a proxy server. And that proxy server is going to have a public IP address right here. And then what we can do on this proxy server is say, okay, if someone's coming in on port 80, always go to my web server here. If someone's coming in on port 23, always go to my, let's say, administrative server here. That's Telnet, right? So really, you're not getting full connectivity because this is only doing now static NAT and adding port numbers to it. So you are kind of cheating the system there with these 3 different IP addresses mapping to one public, but it doesn't matter because you can't now perform HTTP functions on all 3, only the web server. And that's because in this proxy server, you're literally telling it, okay, any connection made to my public IP with this port number on it, you're only going to this web server. And then vice versa. If they're coming to 23, they can only go to one of these servers that you define. So that's kind of a use case for static NAT. Again, you can obviously see the issues in it, not very scalable at all. One unique case that I actually had to use in my home lab for static NAT is I had this network when I was going over CCIE. So this was run in GNS3, which is ran on my computer. So this NAT cloud would give internet connectivity to all these devices, right? And it was performing NAT. So all these private IP addresses were getting NATed to this cloud management device, which allowed them actual connectivity to the internet, all from my GNS3 application. So out on the internet, I deployed a Ansible server. And we'll get into what Ansible is. And Ansible uses port 22 to configure devices using playbooks. So I had an issue where this Ansible server sat at, I don't know what IP address it sat at, but essentially it was outside of my network. So let's just say it sat at 22.8.2.50. When I tried to push configurations to, let's say, this router's IP, let me change the color, or this router's IP, it wasn't possible because it had to use port 22 for SSH. So it can only do one playbook, and I had to choose which one, which kind of defeats the purpose of Ansible, right? The point is to connect to all your devices. So what I did here was pretty much tell my border router here, which is R9, that, hey, if you get an IP address that is coming into 192.168.122.30, which would be this IP address here, 192.168.122.30, and it comes in on this address, you're sending it over to this IP address with this port number. So on the Ansible server, what I did in my inventory file was I actually put that, hey, for this IP address, don't use your default port 22, use port 23. So when my Ansible server tried to push a config to that IP address, 150.1.7.7, it was still using SSH, but I changed the port number to 23. And when R9, or excuse me, 192.168.122.30, when R9 received that, it was like, oh, okay, well, I'm getting an SSH connection to my IP address, but on port 23, that means I need to send it out here to 150.1.77, which would be R7. I don't know where it's at. Oh, the New York router at R7. So that's kind of a unique way that I use static translations, but changing port numbers to actually kind of do mappings beyond just one-to-one for a single IP address, which is kind of like the predecessor to port address translation. Exactly what port address translation does, it just does it dynamically. Okay, so moving on, I hope that didn't confuse anyone too bad. Now let's move on to dynamic NAT. So in dynamic NAT, we actually have a pool of addresses, or public addresses, that can be used on a first come, first served basis. So essentially what that means is, again, we have a unique situation where maybe we have 3 public IPs connecting off to our ISP or internet. And we're going to put those in a pool. And then that pool is going to be used on a first come, first served basis for all of our inside local addresses or our private IPs. So let's say 192.168.10.10 makes a connection out to the internet. It's going to use the first available public IP in the pool. And then let's say 192.168.10.20 does the same thing at the same time. It's going to use the second available public IP address in the pool, and so on and so on. So technically, it's still a one-to-one mapping where really one IP address is only being used for one local address. However, there's a pool that can be used for all your private IPs, but only one at a time. So if we have 3 public IP addresses that we have in our inside global address pool, we can only have 3 users connecting simultaneously, which obviously you must have a very small business if you only have 3 users. So that's dynamic NAT, and I don't have a good example of when we would use that. And now let's get into the moneymaker, right? PAT. So with port address translation, this is going to allow multiple mappings of private IP addresses to a single public IP4 address. And we do this by changing the port in the socket. So PAT is truly the only way NAT can conserve public IP addresses, right? Because we can use a whole /24 on one single public IP address. So it accomplishes this by assigning a unique port number on what we call the socket, which is just a layer up, right? A layer 4 port number. So PAT uses the pair source port and source IP address to keep track of what traffic belongs to which internal client. So let's check this out. So let's say 192.168.10.10 needs to make a connection to our web server here. So when it does that, it's going to, again, create that IP packet. So what we're going to have here in our source packet, and I'm not going to write the whole IP address out, is .10:3000. That's actually going to be our socket, right? And this is going to be the source address. Then let me change my color here. And then our destination address or socket So socket destination address is going to be our outside local address. So .15::80. Well, once it reaches that PAT enabled router, then we're gonna switch it up again. So now we're gonna replace that source address, which is .10, with 65.160.10.1 and keep that port number 3000. Okay, ran out of space there, but that's okay. Hopefully it doesn't look too bad. And then that outside global address now is still the same with the same port number. So that's how it's going to keep track of all the connections that users are making. So we're going to call this the ephemeral port. And that's how we do port address translation. As you can see here, for each connection, each user is going to have a unique port number that gets mapped. Because when this web server is going to respond, its destination port will still be 4000, which our two nodes belongs to 192.168.10.20 on that TCP or UDP stream. Okay, now let's go over static NAT configuration. So static NAT configuration is very simple. There are two basic tasks. So you just create the mapping where you define your inside local and your outside local, or your private IP and your public IP. And then you have to define which interfaces are going to be inside and outside. So your inside is going to be your interface facing your LAN, and your outside interface is going to be the interface facing the WAN or the ISP or the internet. So we can see here, first step, map the inside and outside IP addresses. So as you can see here, on our router, we do a show IP interface brief, and we see our inside address here is fastest internet 00.10. Our outside is this public IP address, which belongs to serial port 000. Then it's one line of command. And that line of command is going to be IPNAT inside, because we're defining our inside to outside mapping. The source, and then right here you have an option to do like pool, static, or I believe an ACL. We're choosing static because this is our static NAT. And then the next command is going to be your inside IP address and then your outside IP address. And that's step one, and that's how you configure that static NAT mapping. And then next, we're going to identify the interfaces. So interface fastest internet 01 is going to be our IP NAT inside. So here's the full command. And the interface serial 001, which is facing the internet or our WAN, is going to be IP NAT outside. Pretty simple. And this command is going to be used in every version or flavor of NAT, every type of NAT. You're always going to find an inside and outside address or addresses. And I say addresses because we could have sub-interfaces, and those sub-interfaces could be 10 deep, and those are all inside addresses as well. So dynamic NAT configuration. So I have 5 steps here. So step 1 is going to be define your pool. So we're going to create an IP NAT pool. We're going to give it a name, and then we're going to give it a start IP and end IP. And again, remember, these are our public IP addresses. So let's say we have 4 public IP addresses that we can use. We're going to put the start and end IP, and then either put the subnet mask or the prefix length that allows you to do either or. And then we're going to configure an access list. And this access list is going to be used to identify the inside addresses that will be translated. Because remember, with dynamic, it's a first come, first serve translation. So we could potentially define a /24. Doesn't mean all the users on our network are going to be able to simultaneously talk, but we can define a whole subnet that needs to be translated. We do that by configuring access list. And then we have the actual IPNAT inside command again. And if you see right here, instead of putting source static, we do list. And that list is going to be the ACL number that defines our inside addresses. And then we're going to say we have to match those to a pool. And then that pool name that we configured up here. And then, of course, our inside outside addresses again. So let's see this configuration, define the pool. As you can see here, IP NAT pool, the pool name, the start and end public IP addresses. Then here we chose to just do the prefix length. So that's a /29, which is going to encompass all those public IPs. Now that doesn't mean that if we did /28 that, oh, well, we're going to use 231, 232 now. Doesn't mean that. This just helps it define it a little bit better. Then we're going to define our inside addresses. And this is always done this way with an access list, whether we're doing dynamic, NAT, or PAT. So here we're going to see, okay, what's our inside address? What's its IP address? So it's a /24 with the 192.168.10.0 being the network. So we just create a standard access list here. We use a permit command to define the addresses that need to be translated, our inside addresses. And then we're going to map our inside and outside pools. So right here, we have to make sure we have the correct access list number so that we do our show commands. And then we have to make sure we have the right NAT pool name here because it matters. And then we have our actual NAT commands. So it's going to be IP NAT inside, source, and then we're going to do list, which means what access list defines our inside addresses. And then we're going to define the pool that will be translating the IP addresses that are inside that access list. And we're going to put our unique pool name that we created and we set. And then, of course, we identify our interfaces, nothing new. We have to decide which one's the inside and which one's the outside. Okay, awesome. So again, I don't want to go past, which I already am past 15 minutes. So we're going to go ahead and stop here. Join us for part 3 when we go over PAT and get into the verification. And then finally, the fun stuff, our labs. So thank you for viewing.